4:07 a.m. Your eyes opened. No sound woke you. No light shifted. No one touched your shoulder. The room was exactly as it had been for hours. Dark, still, perfectly silent, and yet something inside you decided, with absolute precision, that sleep was over. Your alarm was set for 4:15. You were 8 minutes early, and you have no idea why. Most people call this coincidence, a lucky guess by a restless brain. Maybe you were anxious about the morning. Maybe a car passed outside and your subconscious caught the sound. Maybe you just slept lightly. That's not what happened. What happened is far more precise and far more unsettling than anything coincidence could account for. Your body didn't accidentally stumble into waking. It prepared to wake. Methodically, chemically, hours in advance, with a hormonal sequence so exact, so anticipatory, that scientists still aren't entirely sure how it works. You didn't wake up before the alarm. Your body decided to make the alarm unnecessary. Here's what was happening inside you while you slept. Roughly 90 minutes before your eyes opened, something shifted in your blood. Your adrenal glands, two small organs sitting on top of your kidneys like caps on clenched fists, began quietly releasing a hormone called adrenocorticotropin, ACTH, a chemical normally associated with stress. But this wasn't the stress of danger. This was scheduled stress, planned, timed, as though your body had consulted a calendar it never showed you. Then cortisol followed, slowly, rising in concentration the way a tide moves, not suddenly, but with the certainty of something that knows exactly when to arrive. By the time your eyes opened at 4:07, your body had already raised your heart rate, shifted your blood pressure upward, adjusted your core temperature by a fraction of a degree, thinned your sleep architecture from the deep stages into the lightest possible layer, and held you there, hovering until the chemistry said now. You didn't wake up, you were delivered into consciousness. How does a sleeping body know what time it is? In 1999, a German chronobiologist named Jan Born designed an experiment that would quietly change how science understood the end of sleep. He brought 15 healthy volunteers into a sleep laboratory at the University of Lübeck. He divided them into groups. One group was told they would be woken at 6 in the morning. The other was told 9. Both groups actually slept the same amount of time in the same conditions, but Born wasn't measuring sleep. He was measuring anticipation. The group that expected to wake at 6 began producing ACTH at approximately 4:30 a.m., a full 90 minutes before their expected wake time. Their adrenal systems initiated the chemical wake-up cascade on schedule, as if responding to an alarm that existed only as an expectation. The group told 9, their hormones stayed flat until much later. No early surge, no preparation. Born published his findings in Nature. The paper's title was clinical. Its implications were not. The human body, he had demonstrated, does not merely respond to the moment of waking. It anticipates it. It runs a countdown it never consciously announces. It keeps appointments you didn't know you made, but that raises a question far more disturbing than the finding itself. If your body can translate a conscious decision, I need to wake at 6, into a precise hormonal schedule executed entirely without your awareness, then what, exactly, is the boundary between the mind that decides and the body that obeys? Where does the instruction go? Who receives it? Deep inside your hypothalamus, a region no larger than an almond tucked behind your eyes and above the roof of your mouth, sits a cluster of approximately 20,000 neurons. It's called the suprachiasmatic nucleus, the SCN. It is, by every functional definition, a clock, not a metaphor, a mechanism. It oscillates. It keeps time. It sends rhythmic signals to nearly every organ in your body: liver, heart, lungs, kidneys, skin, gut, synchronizing them to a cycle that runs close to, but not exactly, 24 hours. It is the conductor of your internal orchestra, and it never stops playing. In the early 1990s, a molecular biologist at Northwestern University named Joseph Takahashi set out to find the gene responsible for this rhythm. He screened thousands of mutagenized mice, animals whose DNA had been deliberately scrambled. Searching for a single individual whose internal clock ran wrong, he found it. One gene. He named it clock. When it was intact, the mice kept perfect circadian time. When it mutated, they unraveled. They slept erratically, ate at random hours, drifted through their days untethered from the 24-hour cycle that had governed their species and their ancestors for hundreds of millions of years. Takahashi published his discovery in Cell in 1997. What he had found was not merely a gene, it was the molecular mechanism by which biology knows what time it is. The foundation of an internal clock so fundamental that versions of it exist in nearly every organism on Earth, from mammals to insects to plants to single-celled cyanobacteria that have never possessed a brain. That mechanism is running inside you right now. It was running before you were born. It has been running in some molecular form for roughly 3 billion years, and it does not require your permission to operate. But perhaps the most unsettling evidence of this clock's independence came not from a laboratory, but from a cave. In 1962, a 23-year-old French geologist named Michel Siffre descended 130 meters into the Scarron Cavern in the Maritime Alps. He brought supplies for 2 months. He carried no watch, no calendar, no radio, no source of natural light. He had a single one-way telephone to a support team at the surface, who were forbidden from telling him the time or date. He wanted to answer one question. What happens to human time when you remove time? For 63 days, Siffre lived in total temporal isolation. He recorded when he slept, when he woke, when he ate. He had no external cue to anchor him. No sunrise, no temperature shift, no social schedule, no clock face. And yet something extraordinary emerged. His body maintained a rhythm. Not exactly 24 hours, closer to 24 and a half, but a rhythm nonetheless, consistent, repeating, stubborn, even in absolute darkness, even in silence, even without a single external reference point, his biology kept counting. When his team finally signaled the experiment's end, Siffre believed it was mid-August. It was September 14th. His conscious mind had lost an entire month. His body had not lost a single beat. What does that tell us? That the clock does not need the world to keep running. It runs on its own. It was keeping time before you learned what time meant, and it will keep ticking long after the conditions for its meaning have changed. What most people never consider is that sleep is not a uniform state. It is an architecture, a structure built and demolished and rebuilt every night in cycles of roughly 90 minutes. Early in the night, you descend into the deep, slow wave stages, the sleep that repairs tissue, consolidates memory, flushes metabolic waste from the brain through a drainage system called the glymphatic pathway. This is the sleep your body guards most fiercely. But as the hours pass, something shifts. The deep stages grow shorter. REM sleep and the stage of vivid narrative dreaming just grows longer. The body spends increasing time in lighter stages. Stage 2, Stage 1, the architecture thins. By the final 2 hours before morning, you are no longer deeply asleep. You are hovering, cycling through shallow waters. Your brain is already partially processing ambient sounds. Your cortisol has been climbing for over an hour. Your temperature is adjusting. The alarm doesn't wrench you from the depths. It interrupts a process that was already almost complete. It is not the cause of waking. It is the punctuation mark at the end of a sentence your body started writing hours before dawn. So why do we need it at all? Because the modern world has declared war on the clock inside you. Russell Foster, a circadian neuroscientist at the University of Oxford, has spent decades studying the collision between biological time and social time. He has argued that the body does not merely keep time, it negotiates with it. It integrates light exposure, meal timing, habitual routines, social schedules, and behavioral patterns into a predictive model of your day. It constructs tomorrow's hormonal timeline based on yesterday's behavior. But that model evolved for a world that no longer exists. A world governed by sunrise and sunset. A world without electric light at midnight. Without screens at 2 a.m. Without shift work, jet lag, social jet lag, or alarm clocks screaming at a time your biology never agreed to. Foster has described this misalignment as internal desynchrony, a state in which the master clock in the brain and the peripheral clocks in your organs fall out of step with each other. Your liver thinks it's one time, your gut thinks it's another. Your SCN is trying to synchronize a system that the modern world keeps pulling apart. And every morning, when your alarm fires before your body's own preparation is complete, you are not simply waking up tired. You are overriding a system that was trying to protect you, a system that evolved to bring you into consciousness gently, chemically, on its own terms. The alarm is not a tool. It is a confession that we have drifted so far from our own biology that we need a machine to do what our bodies were already doing and doing better for 300,000 years. Consider what waking meant for most of human existence. There were no walls, no locks, no alarm systems. You slept on the ground, in the open, surrounded by predators, rivals, weather, and darkness. Waking was the most dangerous transition of the day, the shift from total vulnerability to survival-level alertness. An animal that woke abruptly, cortisol flat, heart rate low, muscles cold, mind foggy, was an animal that didn't survive the transition, but an animal whose body prepared for waking, whose stress hormones primed the muscles before the eyes opened, whose cardiovascular system ramped up in advance. That animal had a margin, a few critical seconds of biological readiness that meant the difference between reacting to a threat and being consumed by one. Natural selection didn't just favor light sleepers. It favored anticipatory sleepers, organisms whose internal chemistry could model the future, not consciously, not intellectually, but hormonally, architecturally, molecularly. That system is inside you now. It runs every morning, and the alarm clock on your nightstand is its replacement, a crude mechanical substitute for one of the most sophisticated predictive systems biology has ever produced. And this is where the question changes shape entirely, because if this system can anticipate a wake time you chose on a screen, if it can encode a decision into a hormonal schedule executed entirely below the threshold of awareness, then what else is your body predicting that you don't know about? The research suggests more than most people are comfortable with. Your body adjusts insulin sensitivity before meals you haven't eaten. It modulates immune function in anticipation of times of day when infection risk historically peaked. It shifts neurotransmitter balances based on patterns you've never consciously registered. You are not a mind piloting a body. You are a system, a vast, ancient, predictive system that models the future based on the past, calibrated against a planet that rotates whether or not you're paying attention. And the thin layer of consciousness that calls itself you, the part that sets the alarm, that checks the time, that decides when to sleep, is not the commander of this system. It is, at best, a late addition, a consultant, a voice the system sometimes listens to. How much of your waking life is truly yours to decide? The clock inside you is older than your species, older than mammals, older than the divergence of plants and animals. It is one of the most ancient molecular systems still operating in living tissue, a rhythm laid down when the first photosensitive organisms learned that the world turns and that survival belongs to those who can predict the turn. Mice anticipate feeding times. Birds adjust their cortisol before dawn. Cyanobacteria, organisms with no nervous system, no brain, no awareness of any kind, carry circadian genes that oscillate with mechanical precision. Timekeeping is not a feature of complex life. It is a condition of life itself. So tonight you'll do what you always do. You'll set your alarm, place your phone on the nightstand, close your eyes, and you'll believe, as you always do, that you are surrendering to unconsciousness, that the thinking part of you is leaving, and nothing will remain. But something will remain. Something that doesn't sleep. Something that counts. And hours from now, in the dark, in the silence, at a time the chemistry selects, your eyes will open. No sound will wake you. No light will shift. No one will touch your shoulder. Just your body, honoring a rhythm older than your name, older than your species, older than the star that set the rhythm in the first place. You won't wake up. You'll be delivered into waking by a clock that was keeping time before you existed, and will keep time in some form long after you've stopped. And tomorrow, without being asked, it will do it again.